I'm Royston with Lund and Rudershish. We are presenting a project, Advanced Elderly Care System, using Amazon Sidewalk and LoRa. Today, I'm going to talk to you about a critical problem that's affecting millions of Americans. Over 16 million senior adults in US live alone. Among women, 75 live by themselves. Here's the problem. 1 in 4 each of the seniors fall every year. Among 80% of the seniors fall happen at home. Worst yet, the fall rate for the seniors who live among themselves is 73%. Adding to that, the existing wearable health monitors available in the market have a critical flaw. They rely on Wi-Fi, Bluetooth, or cellular connectivity. But what happens in basements, in rural areas, or simply out of coverage? That's the gap our advanced elderly care system addresses. So why Amazon Sidewalk or LoRa instead of traditional approaches? Let's compare the options. First, the Wi-Fi. It requires constant infrastructure and power. Bluetooth has a limited range of 30 feet, and cellular demands expensive monthly subscriptions and drains your batteries really fast. Our solution, Amazon Sidewalk over LoRa, gives us long-range communication up to 10 kilometers, which is far beyond Bluetooth, ultra-low power consumption, and no monthly subscriptions. This means seniors can be monitored anywhere in real time within the sidewalk network coverage, which is almost everywhere in US with no infrastructure costs. Let me walk you through a system block diagram. On the left, we see a variable endpoint, which can be one or multiple. It has a controller, a LoRa module, and sensors, which I'll be explaining you in detail in a moment. This data is then sent to the nearby gateway, which is nothing but an Amazon Echo Dot or Ring devices, which already the homeowners have, or which is nearby in the community sidewalk network. This data is then sent to the AWS IoT core using the Amazon Sidewalk application stack, and finally, the caregivers access real-time data to their mobile or web dashboard. The key here is, once the system is set, the data flows automatically from the variable endpoint through the Amazon Sidewalk application stack up to the cloud, and later the caregivers access real-time data and critical alerts. Let's zoom into what's actually inside a variable. For our hardware setup, we have a Nordic controller with a powerful Cortex-M4 processor. For LoRa communication, we have a Semtech module which runs on 915 MHz band. This is where we achieve the low cost and long range transmission, which I mentioned earlier. And finally, for software, we have Zephyr RTOS, which is integrated with Nordic SDK and Amazon Sidewalk SDK. This completes our entire software development environment. So let me walk you through what we actually monitor. We monitor 3 main categories. First is the vitals. Here we use a PPG sensor. We calculate the heart rate, SpO2, and the temperature. Later on, we have the motion. We use a 6-axis IMU sensor, where we take the accelerometer, gyroscope, raw data values, and detect the fault direction. How the fault detection works is, first we calculate the free fall, the impact, and then the post-impact. And finally, we also send the location coordinates. Through all, we make a payload and send it over LoRa. Now, I'll hand it over to Lan to explain how this data is sent over Sidewalk.
Hi everyone, are you guys still with us? Yes. Thank you. Now let me walk you guys through how our device from hardware layer connects to Amazon Sidewalk and sends data securely to the cloud. When the device first powers up, it uses Bluetooth low energy to find the nearby sidewalk bridge, like an Echo Dot or a Ring device. The bridge then helps provision the device and synchronize tab. After the setup is done, the sidewalk link switches to LoRa for regular communication. And LoRa actually gives us longer range and lower power use, which is important for a wearable health device. Data security plays a very critical part in this application. The Sidewalk protocol uses 3 encryption layers to ensure that only our cloud can decrypt the data. The key point here is that all the Sidewalk bridge owners cannot see your data, and even if your neighbor can relay your messages through the Echo Dot, they still cannot read it. Our system has 3 types of messages: regular for routine monitoring, emergency for detected problems, and help when user presses the panic button. All messages flow through these 3 security layers before arriving to the application layer. Next, please. Now, let's look at how we handle each message type differently. Regular messages are sent every 5 minutes. We use fire and forget for this message type. No checking needed. Emergency alerts are sent immediately when the system detected a phone or abnormal reading, like SpO2 below 90%. Help requests are sent immediately as well when user presses the panic button. This is the manual override for any situation. For emergency and help messages, we use a ring buffer to store messages in a queue, and the system then keeps retrying to send messages until the cloud sends back an acknowledgement. Here is our JSON payload format with 10 fields. The payload is constrained within 19 bytes in binary, which is purposely optimized for lower transmission to Sidewalk. In our testing with an Echo Dot nearby, we performed an overnight test sending data to Amazon Sidewalk every 20 seconds. We measured 1 to 3 seconds end-to-end latency and 100% packet delivery rate. This is fast enough for emergency response. This strategy is designed to balance LoRa's bandwidth limit with reliable emergency delivery. On the slides, you can see a map showing Amazon Sidewalk's LoRa coverage in Southern California. The darker blue area have strong coverage in Los Angeles, Irvine, and most urban areas. This is good news for our use case since most elderly users live in suburban or urban areas. And next, we will move over to Rukrashish to talk about our product's user experience, user interface, and the application layer.
So this is my favorite part in the application because this is where a device goes from just being a mere hardware to actually helping someone. Onboarding is simple. Just go to the onboarding page, enter your device ID, give it a name, and then you click on the register device. That's how simple we have made it to onboard your device. From box to baseline in minutes. No Wi-Fi passwords, no Bluetooth pairing failures. Just that's how simple it is. And once you have onboarded your device, you can go to the dashboard where you can see the analytics. Once the device goes live, this is where the insights live. And this is where you can see heart rate, vitals, and fall detection insights. And then you can also see alerts and the notifications in the dashboard. You can also acknowledge it for the caregiver to see it. And then, since emergencies don't really happen just indoors, we also have on the UI, you can also see the device location, and then you can pinpoint where has the incident happened. This can be the difference between confusion and immediate help. Now talking about our cloud infrastructure, so once the messages are received by the IoT core, the uplink Lambda handles and processes the messages and stores the vitals and the alerts in DynamoDB tables. Internally, we also use CloudWatch to store the logs, and then the APIs are wrapped and using Lambda and served using an API gateway, which are fed to our dashboards. The design is supposed to be scalable and fully pipelined for a robust deployment. And so by intelligently combining LoRa's range, Amazon Sidewalk's community network, and AWS's scalable cloud infrastructure, we have engineered a solution which can address a critical gap in elderly care. We believe that technology should empower people to live more freely and safely at every stage of their life, to maybe garden without worrying, to maybe walk your dog with confidence. The possibilities are endless. And with that, thank you so much for listening to us, and we would love to